Let's solve a calculus problem involving repeated differentiation. We'll prove step by step that when given 2y equals tangent inverse x squared, the second derivative satisfies a specific equation. Let's start with our initial equation, 2y equals tangent inverse x squared. To solve this, we'll need to differentiate both sides with respect to x. For the first differentiation, we'll use the chain rule. On the left side, we get 2y sub 1. On the right side, we get 2 times tangent inverse x times the derivative of tangent inverse x, which is 1 over 1 plus x squared. Now, let's rearrange this equation. Multiply both sides by 1 plus x squared, and we get y sub 1 times 1 plus x squared equals tangent inverse x. For our second differentiation, we'll use the product rule on the left side. The derivative of y sub 1 is y sub 2, and we multiply that by 1 plus x squared, plus y sub 1 times the derivative of 1 plus x squared, which is 2x. On the right side, we get 1 over 1 plus x squared. To get rid of the fraction on the right side, multiply both sides by 1 plus x squared. This gives us y sub 2 times 1 plus x squared plus 2x y sub 1 times 1 plus x squared equals 1. And there we have it. We've proven that when 2y equals tangent inverse x squared, its derivatives satisfy the equation. Y sub 2 times 1 plus x squared plus 2 times 1 plus x squared times x times y sub 1 equals 1. This proof demonstrates the power of repeated differentiation and algebraic manipulation in calculus. We use the chain rule for the first derivative and the product rule for the second derivative, then simplified to reach our desired result.